This is lesson 2.3b. We're going to talk about applications to solving linear equations. So your objective for today will be you will be able to solve real-world applications by setting up and solving linear equations. So let's take a second to review some important things we're going to need to know for today. So below I have listed the 4 basic operations: addition, subtraction, multiplication, and division. I want you to take a second to think about what types of words, English words, would translate those operations. So when you see addition, what English word would translate that? What verbal translation would be? So for addition, increased by. If you see the word increased by, you're going to be adding. Sum. If you see the word sum, that just means the answer that comes about from an addition problem. So that will denote addition. Total. If you go to the store and they tell you your grand total, all they're doing is taking all of your merchandise and adding it up. More than. If you see the word more than, that's going to denote addition. I am 2 years more than her. That'll denote addition. Subtraction. You see the word decreased by. That means subtract. Difference. That's the word that just means the answer to a subtraction problem, so that denotes subtraction. You see the word less than or the word less. All of those you're going to use subtraction. For multiplication, you see the word product. Product is what we call the answer to a multiplication problem. That'll denote multiplication. If you see the word twice, that just means 2 times something. Per. Is going to denote multiplication as well. You know, gas is $3 per gallon. So take $3, times it by how many gallons your car can hold, and that's the price you're going to pay for your gas. If you see the word of, 2/3 of her salary, a half of her total purchase. Those are all phrases that will denote multiplication. Make sure you memorize those. Division. You see the word half, you're going to divide by 2. Quotient is what we call the answer to a division problem. And then, of course, if you see the word divided by. All of these words are very important words that you need to memorize and be on the lookout for. When you're reading an application problem and you see the word increased by, a little light bulb should go off. That means addition. If you're reading a problem, you see the word per, light bulb, multiplication. These are all words that you need to pick up on when you're reading word problems so that you can get an equation out of that word problem. Okay? So many students start to panic when we talk about application problems. If you can be organized and put pencil to paper and show your work, word problems are not that bad. Practice is key, and showing your work is most important. So always start by setting up your problem. That means define your variables. Determine what it is you're trying to find out. Are you trying to solve for how many pounds of apples they bought? If so, you need to figure out how you're going to find that. This is your game plan. This is your plan of action. So this is where you define everything and set an equation up. Step 2 is the easy part. That's what you've been doing all along. Step 2, you're just going to either evaluate or solve the equation you set up. As simple as that. Step 3, check your answer. You guys have been doing that all along as well. This time it should be pretty easy to check. Did you answer the question being asked? If it asked for how many baseball cards Johnny purchased, and you get an answer of -18, does that make logical sense? No. Can you get -18 baseball cards? You can't. If you got an answer of 1.0345, how do you get 0.0345 baseball cards? So there's certain times where decimals it'll be obvious if you're dealing with money, if you're dealing with pounds, if you're dealing with weight, volume, anything like that, decimals are probably a safe bet. If you're dealing with people, if you're dealing with objects, decimals are probably not going to come about. So if you get a decimal, check your work, make sure it makes sense. Negatives. You shouldn't get negatives unless we're dealing with either temperature or, in the rare case, money, and that would just mean you're in debt. It is very rare to get a negative in an application problem in Algebra 1. So if you get a negative, check your work. And make sure you always label your answer. If you're dealing with pounds, make sure you label pounds. If you're dealing with money, make sure you put a dollar sign. That kind of stuff. Okay? Let's dive right into it. Let's try an example. So our first problem, Sam has $1,900 in the bank. He wishes to increase his account to a total of $2,500 by depositing $30 per week from his paycheck. Write and solve an equation to find how many weeks he needs to deposit money to reach his goal. Alright, so our first step, we need a plan of action. Take a second to read through that problem and figure out what it is we're trying to find. What do we need to know? What do we need to find out? If you look, it says right here, find how many weeks he needs to deposit money. So, we're trying to figure out how many weeks he needs to deposit money to reach his goal. Simple as that. So now we need to define a variable. Remember, a variable represents something that is unknown in a problem. So once you determine what you're trying to find, that's what your variable is going to be. So our variable will just be x equals the number of weeks. So it's really important that you're able to start analyzing these problems. If you can go through these mental, analytical steps each time, word problems will become a lot easier. And then this is the part where a lot of students tend to struggle with, is writing the equation. Okay? This is where those translating words come into play, and reading the problem and translating word by word. If you can do that, you're golden. So I'm going to start by reading through the problem again and trying to come up with an equation. My first sentence, Sam has $1,900 in the bank. Okay, that $1,900 is in the bank. It is not going anywhere. He is trying to save money. He's not going to be spending that. That is a fixed amount. It is in the account, present. So we have $1,900. He wishes to increase his account to a total of $2,500. So that's what we're going to end with. We're going to end with a total of $2,500 in this account. He's going to do this by depositing. So when you deposit money into an account, you're not withdrawing it. You're not taking it out of the account. You're adding it to the account. If you get a paycheck that's deposited into your bank account, it's going to increase the amount of money in that account. So that deposit word means addition. If you want to add that to the list of words from earlier, it's probably a good idea you do so. He's going to deposit $30 per week. Look back at those words. Per means multiplication. Per week, well, week is our x, so we get 30x. And this system is supposed to give him a grand total of $2,500. So there is your equation, okay? So now comes the easy part. Let's solve it. 1900 plus 30x equals 2,500. Subtract over 1900. Bring down your 30x equals 600. Divide by 30. X equals 20. Let's make sure this makes sense. Let's check our answer. 1900 plus 30 times 20 gives us 1900 plus 600, which is 2,500. So label your answer. A complete answer is always labeled. Sam will need to deposit money for 20 weeks. After depositing $30 per week from his paycheck, he'll have a total of $2,500 in his account. Next problem. Austin is earning money by painting houses. He charges a $200 fee plus $12 per can of paint needed to complete the job. Write and solve an equation to find how many cans of paint he needs for a job that is bid at $260. All right, well, we need a plan here. So what are we trying to find? Well, we are trying to find how many cans of paint is needed for a $260 job. So the key is how many cans of paint. So when I define my variable will be x equals number of cans of paint. So now I need to write an equation. I'm going to start by just reading through the problem again. Austin is earning extra money by painting houses. He charges a $200 fee. So $200 is what it costs him to show up at your house before he puts his paintbrush to your wall or whatever it might be. For him to show up at your house is $200. Plus $12 per paint can. Write and solve an equation to find how many cans needed for a $260 job. So this bid is equal to 260. We need to figure out what value for x would make this job $260. So now we need to solve. So I'm going to subtract over my 200. I have 12x equals 60. Divide by 12. X equals 5. 5 cans of paint. That seems pretty reasonable, but let's check to make sure it makes sense. I'm going to replace x with 5. 12 times 5 is 60. 200 plus 60 is 260. So Austin needs 5 cans of paint to complete the job. Alright, now it's your turn to try it out on your own. Here's the problem. I want you guys to read through this. Try to figure out what you're solving for. Set up an equation, solve the equation, and then check your answer. Okay? Your answer should be 475 home runs. Okay? If you have any questions on this problem, put a star by it, circle what part of it you don't understand, and make arrangements to come see me in class. Next one. A rectangular swimming pool is surrounded by a concrete sidewalk that is 3 feet wide. So here is that picture. Here is your concrete sidewalk. It is 3 feet wide. The dimensions of the rectangle created by the sidewalk are 21 feet by 31 feet. Find the length and the width of the pool. Find the area of the pool. So there's 2 things we need to do. So let's talk about plan A. So the first thing we're going to look at for plan A is finding the length and the width of the pool. So above I have listed some helpful formulas that may be of use to us for this problem. This is our area formula and this is the perimeter formula. So we need to find the length and the width of the pool. So we're looking for those yellow regions there. Now the sidewalk is 3 feet wide. So that means from this point to the pool is 3 feet. This point to the edge of the sidewalk is 3 feet. So if we know the total length of the sidewalk is 31, if I subtract off my sidewalk, which will be 3 feet on the left and 3 feet on the right, I should get my width. Same thing with my length. There's 3 feet of sidewalk here, and there's 3 feet of sidewalk here. If I take this 3 feet and this 3 feet and subtract it off the 21, I should have the length of my pool. So my plan here is to subtract 6 from 31 and 21, and that will give me my length and my width. So my evaluate step, I'll take 31 minus 6, and that gives me 25. 21 minus 6 gives me 15. So the length is 25 feet and the width is 15 feet. So that's my first piece of information I was trying to find, the length and the width of the pool. Next, plan B, we need to find the area of the pool. Well, lucky for you all, I've listed the area formula up here. Area is just length times width. So, I'm looking for this entire area right here. Just the area of the pool, not the sidewalk. So I'm actually going to have to use the information I solved for in part A. The area formula, as I said, is listed above. You will need to memorize this moving forward, though. This is a very important formula. It'll come up all the time in your application problems, in geometry. It's very important you memorize it. So area is just length times width. My length is 25, my width is 15, so the area of the pool must be 375 feet. And that is my final answer. Alright, so now I want you to take a second to try this problem out on your own. Read through it and see if you can set up an equation and solve for the number of tent stakes that Joey bought. So here is what my plan looked like. I figured out we needed to determine how many tent stakes Joey bought. So I let my variable x equal number of tent stakes. When I wrote my equation, reading through the problem, it says Joey bought 3 times as many packets of drink mix as tent stakes. He also bought 2 more bottles of water. Remember, more than means addition. All of those items together should total 18. So then I just simply solved. I combined like terms and solved to get x equal 4. Plugged in and it all worked out. So Joey bought 4 tent stakes. If you have any questions on this problem, put a star next to what it is you don't understand and come see me in class to get further information on it. I know these word problems can be tricky sometimes and it's kind of fuzzy to understand. Do not hesitate to come see me and talk with me. Just make sure you can pinpoint what it is you're not understanding. Make sure it's not just, I don't understand how to solve all the word problems. I need to know what part of it you're struggling with. So here's our final problem. So our objective today was to solve real world applications by setting up and solving a linear equation. So here's your last problem. It is multiple choice. Read through here and see if you can determine what the answer is. Well, actually the answer is H. Make sure you get that. If you have any questions on this problem, make sure you come see me for help.